Sure. So we'll try to get Catherine O'Reilly on the phone so she'll join us to be able to answer questions. What I'm presenting today is work that is published in GRL today, and it is a global analysis of lake temperature trends that is the largest yet, and indeed demonstrates that lakes are warming rapidly. It's the work of about 64 co-authors, and 4 of those lead authors are Catherine O'Reilly, who we're trying to get on the phone right now, Sapna Sharma, Derek Gray, and myself, and 60 other contributors, including Simon Hook, who has a great deal of expertise in satellite estimates of lake warming. So this is a collaboration that was brought together with support from National Science Foundation and also NASA. And we will talk today about how many lakes are warming faster than air, and especially at higher latitudes. And we'll talk a little bit about some of the implications of warming for our freshwater resources. So we've known for a long time that oceans and air are warming, but this sort of data synthesis at a global scale has not yet been done for lakes.
There she is.
We've got Catherine. So
I'm back. I'm sorry.
That's all right. So Catherine, I just got started, and I sort of introduced. Great. And so now I am on slide 3 if you want to take it from there.
Yeah, thanks, Stephanie. Thank you so much.
You bet.
So as Stephanie said, we've known for a long time that that air temperatures are warming and that ocean temperatures are warming. And we have a global average air temperature warming rate and a global average ocean temperature warming rate, but we don't have any kind of a global average warming rate for lakes. And that's a little bit surprising because lakes are a really important freshwater resource. So we get our drinking water from lakes. Lakes are a critical source of protein in terms of fish for many countries of the world. And lakes also have a lot of recreational and cultural value. So this study that we're publishing today is the first global analysis that uses both satellite and hand-collected temperature data from lakes to determine what the global average lake warming rate is. Next slide. Okay. So this slide has a map on it, and this map shows the surface temperature trends for the 235 lakes in our study. The global average warming rate that we found for lakes was 0.61 degrees Fahrenheit per decade. This rapid rate is higher than the overall warming rates for oceans or for air temperatures. And in fact, for us, this was one of the surprising findings in our study. We were expecting maybe to see, on average, lakes to be warming about as fast as air temperature, or maybe a little bit slower than air temperature. So we were very surprised by how fast lakes are warming on average around the globe. Also, if you look at the map, you could see that there's a lot of variation. The warming rate varies a lot from lake to lake. And this was another thing that we were surprised by. So, for example, if you look at the eastern North American region, you could see that all the lakes there aren't warming at the same rate. And in our study, we found that this is in part due to the fact that the size of the lake, how deep it is and how big it is, has a big impact on how fast lakes can warm up. So as an example, if you live near Lake Michigan or Lake Superior, you know that in the summer, you're perfectly comfortable swimming in a smaller pond early on in the summer, but you don't really want to venture out into swimming in Lake Michigan or Lake Superior until much later in the summer, like August. Next slide. So many of the lakes in our study are warming faster than air. And in cases where water temperature is rising faster than air, for some lakes, this might be because they have shorter ice cover, which gives them a longer period to be exposed to warming the sun. We found among the lakes in our study that the fastest warming lakes were lakes that do experience some level of ice cover, that were also experiencing increases in summer solar radiation and decreases in summer cloud cover. Next slide. For other lakes that are warming rapidly but that don't experience ice cover, it might be because of things just like cloud cover decreases in the region, which allows more solar radiation, more sun to warm the lake surface. So in our study among the lakes that are ice-free, that don't experience winter ice, we found that the highest warming rates occurred in cases where both summer air temperatures were increasing and summer solar radiation was increasing. Temperature sets the stage for basically everything we really care about in lakes. And so the kinds of changes that we're seeing in our study have a lot of implications for these freshwater resources. So now I'm going to hand the microphone over to Simon Hook, who's going to talk a little bit about the process of measuring lake temperatures and what's unique about the way we use lake temperatures in the study.
Thank you, Catherine. So if we look at the next slide here, we see a picture of a couple of researchers lucky enough to get to go out and work on a lake. But this picture of these researchers in this small boat highlights one of the important things about including ground measurements as well as satellite measurements. And that is that from a boat, you can take measurements beneath the surface of the lake, whereas the satellite measurements will only measure the actual surface of the lake. So people have been going out in boats like this and making these kinds of measurements. And so some of for many years, and so some of the longest records that we also have come from these kind of boat measurements. But the other thing that you notice when you look at these boat measurements is that you realize that it's not practical to go out and sample every lake, and in addition to that, that you can only make these measurements under certain conditions. So if it's nice and calm, like on this particular day, it's very easy to go out and make these measurements, but if it's not so nice, it's much more difficult. Furthermore, the scientists, when they're out there making these measurements at different places, they may make them in a slightly different way. So they may measure them at slightly different depths and things like that. So there's a little bit of inconsistency there in the record. Now, in order to address that, what we've done is we've developed these autonomous systems which make the measurements continuously. And then this next slide here shows a picture of one of these autonomous systems. This is a buoy that's on Lake Tahoe, just to the east of us. It's actually one of 4 buoys that were put in around 2000. And these buoys measure the temperature of the lake on a near continuous basis. In fact, we've been measuring it every 2 minutes since 1999. And from these buoys, we can also measure underneath the surface as well as at the surface. And when we measure from the surface, we use these things which are called radiometers. And these radiometers, I've actually got one in my hand here, sit on the boom that extends out from the buoy. And they sit like this, and they scan down, and they actually look and measure the radiation coming off the surface of the lake, and they convert that into a temperature. Now, the satellites really do exactly the same thing. It's the same kind of instrument, and the only difference is, of course, it's on a satellite. And one of the big advantages with the satellite data, of course, is that we can actually measure many lakes all at the same time. So when we look at this next slide here, we see some pictures from what's called the MODIS instrument, and you can see all the lakes in the southwest region. You can see Lake Tahoe there in the center. You can also see Pyramid Lake and Honey Lake, and then Mono Lake, and you can see San Francisco there in the west. And so with these satellite images, we can look at all of the lakes. And this particular instrument on this satellite, which is called MODIS, flies over every day. And so we get a sampling every day. But it doesn't take really detailed pictures. And so for that, we need other satellite instruments which allow us to take more detailed pictures, but they're just a little bit less frequent. We get them a little bit less frequently. And so if you look at the inset in there, that's a picture from another satellite instrument called ASTER, and that gives us these more detailed pictures. And when you look at that, what you can see is you can see cold water, which is colored blue in the western part of Lake Tahoe. And then what's happening is the wind is blowing across the lake, and so the warmer water is getting pushed over to the east, and the cold water is rising and then getting pushed over over to the east as well. So it gives this pattern, which in this particular case looks a little bit like a pterodactyl in the lake, but it's actually this cold water that is moving across the lake. So that gives you a feel for the sorts of information we can get from the satellite data versus the ground measurements. And what I'm going to do now is hand it over to Stephanie, and she's going to talk a little bit about the consequences of that warming on lakes.
Great. Thanks, Simon. Once you see the pterodactyl in that image, you really can't unsee it, can you? It's really cool. So understanding warming trends is really important because, as Catherine alluded to, surface waters are incredibly important for human society. And in fact, worldwide, human societies depend on surface waters for the vast majority of human uses. So drinking water, irrigation for our crops, water for manufacturing, for cooling and energy production. And temperature really affects every aspect of those water resources. It affects directly the availability of water. It affects water quality in many ways and habitat for fish. One of the most dramatic effects of warming can be something like what you see here in this slide from our colleague John Small and Marianne Douglas. And this is the case where an aquatic ecosystem entirely disappears from evaporation. So John and Marianne and their colleagues have been working here for about 20 years or more, and they have extensive paleo records from this region as well. And those guys weren't involved in this study, but they shared with us some of their findings. And in the paleo record, it shows that this sort of shallow system of ponds in the Canadian high Arctic really haven't gone through this sort of extensive drying in the past. So this is something that is unprecedented in the thousands of years of records that they've had access to. And John and Marianne call this crossing the final ecological threshold for an aquatic ecosystem when the water is simply gone. And I want to be clear that we would only expect this sort of phenomenon in the shallowest lake ecosystems that are experiencing warming, but it is a very good reminder to us of how much water level can change with evaporation, and that can affect the availability of our fresh water, and it can also affect the nearshore habitat for fish and other animals that rely on nearshore habitat for their feeding and for their breeding. Now, in some lakes that experience a lot of nutrient pollution, warming can work together with nutrient pollution to promote nuisance algal blooms, and many of these blooms can be toxic. So you would notice this as a visual, very apparent sometimes when you fly over a lake that's experiencing a large nuisance level of algal bloom. You would certainly notice it if it's happening in your local pond. And many of us, I think, have lived near local ponds that experience nutrient pollution and give us this vibrant green water at times. Now, in the best case scenario, this sort of nuisance algal bloom is just smelly, it's unpleasant for swimming, but as they become more serious, the smell, so the odor and the taste can be affected if it's a drinking water supply, so that municipal operations may need to alter their treatment of the water so that they can provide palatable water for their communities. And of course, in the worst cases, some of these algal blooms can be toxic to humans, fish, and wildlife. In other lakes, warming can in general, warming can reduce the availability of oxygen to fish and other organisms as well, especially in those ecosystems that experience high nutrient pollution. So where it's a warm environment and you have nutrient pollution, algal blooms can proliferate and further reduce the amount of oxygen that's available in the lake. And in the Salton Sea, fish kills occur when you have a congruence of high temperature, really strong winds, and big algal blooms that lead to very low oxygen conditions and can expose fish to these anoxic or low oxygen waters that are in the lake and lead to a fish kill. In other lakes, we see a very different kind of effect of warming. So this is Lake Tanganyika, where our colleague Catherine O'Reilly has been working for some time. And Catherine and her colleagues show that warming has led to lower productivity in this ecosystem. So warming can reduce the lake's ability to mix its nutrients that fuel algal growth, and in this case, reduces algal growth in Lake Tanganyika and may ultimately affect the amount of food that is available to fish. And Tanganyika reminds us that while it's tempting to look at the highest rates of warming that you might see on the table in our paper, some of those lakes that have lower rates of warming may also be experiencing very important ecological effects. So in Lake Tanganyika, it's already a very warm lake. And so even a modest temperature change can be stressful to the fish and other animals in that lake because they may already be living very close to their physiological tolerance. And in Tanganyika also, we think about the importance of fish as protein in the developing world. So in many parts of the developing world, freshwater fish are really a critical source of protein, so that the way that warming changes these ecosystems is not just a nuisance or an economic hardship, but is really a matter of health and welfare for human communities as well. And in cold water lakes, they may also be sensitive to warming. So I'm showing a slide of Lake Baikal in Siberia, in Russia. And Lake Baikal is home to the world's only exclusively freshwater seal. And Lake Baikal is the oldest lake in the world. It's about 25 million years old, so there's been a lot of time for animals and algae to adapt to very cold water conditions and to long periods of ice cover. And so those animals and algae can be very sensitive to changes in temperature as well. So I've been working at Lake Baikal for about 10 years with my Russian colleagues, and my Russian colleagues have been working there since the 40s and probably earlier. And the temperature changes that have been seen in the summer at Lake Baikal are pretty dramatic. In the 1940s, a common water temperature might have been about 40 degrees Fahrenheit, and around 2000, you might be more likely to see summer water temperatures that are closer to the mid-50s sometimes. And to give us a sense for what that might be like, that's sort of the difference between swimming in the Pacific Ocean near Seattle and swimming in the Pacific Ocean near San Francisco. And both of those temperatures are too cold for me without a wetsuit personally. But really that temperature difference also doubles your time to hypothermia. So that kind of change in temperature can have very strong effects on animal physiology. So it might be a little more comfortable for us, but it's stressful for animals that have evolved to cold water conditions like the Lake Baikal seal. Oops. So our study really demonstrates that the changes we see or the changes we would expect with climate change are not only imminent, but they are actually underway. And I think that a lot of us find it frustrating to hear yet another story about climate change and warming. And I find it frustrating to report on such a dramatic case of warming in our world's lakes. Frequently climate change can seem like an inexorable force. We know that slowing, stopping, and reversing the temperature trend is going to take a long time, even under the best case scenarios. And I don't want to end on that message because I really do see a positive in understanding the extent of warming in our world's inland waters. So, for example, many of the negative consequences that I've just talked about are actually the effects of warming in concert with pollution and other human impacts that are more directly under our control. And so as our global leadership works towards solutions that will more directly address the temperature trends that we're talking about here, in the meantime, at regional, local, and individual levels, we can recognize what the extent of warming it is, what that extent might be in our local ecosystems, and we can address those impacts and other stressors on our lakes that might be more directly within our power to curb, such as pollution. So thank you very much.
Thank you. Thank you. We will now open the floor to questions. Just a reminder that only reporters can ask questions. Please state your name and affiliation. Thank you.
My name is David Appel. I'm with Yale Climate Connections. I have a couple questions, and I'll ask them separately. One is, over what time period is your trend of 0.34 C per decade, and what is your baseline?
To 2009 period.
2009?
Yes.
Do you have a baseline?
The numbers were referenced to that baseline.
Okay. Do you plan to make a time series out of this eventually? Will you keep doing these measurements in order to get a long time series?
Yes, the plan is to keep doing those measurements, and obviously this study is reported out until 2009, but there have been several years since then, and so we just keep adding to the record and building the record up. But periodically we sort of take a step back and then do all the analysis.
Can you derive changes in, say, lake heat content, and determine or estimate the global energy imbalance like they do with the Argo buoys that dive down to 2,000 meters in the ocean?
We can do that, but we can only do that for a select number of lakes where we've got measurements in the lake as well. So we understand what's going on beneath the surface as well as what's going on at the surface.
Yeah.
Could you repeat that? So you don't have as good of information below the surface? Is that what you...
So there are only a small number of lakes which have been sampled beneath the surface. And so we need information, in order to get at the heat balance, we need information on what's going on beneath the surface as well as what's going on at the surface.
Hi, my name is Bas den Hond. I'm freelance. I'm from the Netherlands. You skipped my country, I'm afraid to say. But that gave me the energy to look at some other lakes. Funny enough, 2 days ago I was at a session on climate refugia, places where, for topographical reasons, for instance, cold air will pool at the bottom of a valley, and basically wildlife there can escape climate change. Mm-hmm. And the example one example of that is Lake Tahoe. And I see here that Lake Tahoe has a pretty high rate of temperature change, so maybe people should talk. Yeah. Or the two phenomena might be compatible, and then I would want to know about that.
The Refugia study was more based on terrestrial animals, yeah? Yeah, because Lake Tahoe is one where the processes are pretty well known, and there are some pretty strong rates of water temperature change there, yep.
Which does not somehow negate the warm the pooling air there? How is it possible that terrestrial temperatures can be very low there, even though the lake is warming at a high rate?
Right. I think one of the points that we should make a little bit more clearly is that these are the rates for the summertime. Mm-hmm. So these are summertime, in the case of the satellite data, they're summertime, nighttime rates of warming. So, if you're looking at a situation where it may be the effect of a winter phenomena or something like that, then that's a little bit different. But the reason that you get the situation where the lake is not in sync with the air temperature is because there are a lot of other things going on. For example, the amount of cloud cover may be going down. It may be that the lake is not ice covered for as long, or it may be something like that the colder water is running into the lake, and that's affecting it as well. So all of those different processes going on at the same time are what really control the fact that the lakes can end up warming more rapidly than the air temperature, which will be changed in an instant. And so really lakes are great integrators in terms of what's actually going on the surface and for these ecosystems, whereas an air temperature will just change suddenly, where the lake represents sort of an integrated temperature.
Okay, thanks. And then there's another lake that interests me. In the previous press conference, we heard about Lake Taihu. Taihu, yes. I'd never heard of it, but it's the largest lake in China, I believe. It's very shallow, and it's completely mucked up with algae. cyanobacteria. And it hasn't warmed at all. Is that a coincidence, or is there anything special going on with that lake, or did it get so dirty that people stopped measuring there?
Well, I think all of these questions that focus on a specific lake are going to be pretty tough to address because there were 235 lakes in the study. As Simon was mentioning, there are a lot of factors that affect the warming rates. And so, in the Tibetan Plateau, for example, we saw some cooling and we saw some very low warming rates for some of those lakes. And in that case, it was a matter of the glaciers actually melting and contributing meltwater to the lakes, which cooled them down. Also, cloud cover changing and the amount of sun that reaches a lake to make it warm, in addition to those air temperature changes, are also really important factors. So without getting back into our analyses and our results to figure out exactly what the trends were for each lake, I'm sorry that it's so difficult to answer a question about any specific lake in that list.
All right, so there's no common denominator to lakes that haven't warmed.
So, well, I think basically the common denominator is that they're all rising. In terms of temperature, or the majority of them are rising. But I think that if you want to look at a specific lake, then there'll be differences over a relatively short area between lakes. But just in general, the lakes are rising, and that's what we see with this study. Before, when limnologists or people who study lakes would tend to focus on their own lake, and they weren't really aware of what was going on at other lakes near them or other lakes further away. And by bringing all of these ground studies together with the satellite studies, we're able to look at that big picture and stand back a bit and see just what the general trends are, as well as then go back and look in more detail at what's going on at an individual lake.
I think we have a question on the chat.
Hi, I'm asking this on behalf of Lenore Sabota from the Pantograph, and she asks, Stephanie Hampton mentioned other factors are more within our control. What are some of the things that can be done, such as limiting the influx of nutrients?
Yeah, so I think that the pollution is one of the issues that keeps coming up as we talk about what are the potential impacts on our freshwater supply, because warming does tend to exacerbate the effects of nutrient pollution. It can also exacerbate the effects of heavy metal pollution, in the sense that if a lake has heavy metal pollution that might be in the sediments, if the warming helps to contribute to lower oxygen near those sediments, in the water near those sediments, it can also bring metals out of the sediments and into solution. And so it's important to factor in the current and future rates of warming into our plans for how to control nutrient and other forms of pollution. And I think how you go about controlling pollution certainly depends on the type of lake and the sort of pollution that it is receiving, so that in many cases people are thinking about controlling runoff from agriculture or other types of human development. In other cases, people may think about the way that they treat sewage that is being contributed to lakes. But that's certainly one of the issues that people can help to keep track of as lakes are warming.
And I think just to add to that, if you take Lake Tahoe as an example, there have been lots of things that have been done. For example, they've switched from 2-stroke engines to 3-stroke engines for boats on the water. They have looked at ways to reduce the sediment that goes into the water, to actually control that, to reduce the amount of phosphorus and things like that that get introduced into the lake. They've even looked at the effects of burning wood and the large particles that come out being deposited into the lake. So there are lots of different ways that you can actually do something about the pollution that's going into lakes.
Are there any other questions from reporters in the room? Okay.
So I'm wondering how to characterize your trend. did you weight lakes by area?
The lakes were not weighted by area, so you know, we're looking at all of the lakes together. We don't weight one more than another.
And how did you select which lakes to look at?
So, in large part, it's been driven by the satellite data, and that's because, as I mentioned before, there are these satellites that go over every day, but they can only really look at large lakes. So that, you know, these 260 odd lakes are all pretty much large lakes. There's a few smaller ones where there have been some ground measurements, and we've incorporated those into it. But in large part, it's been driven by the fact that we need the larger lakes to be able to see them from the satellite data.
Well, and I think also driven by the availability of the in situ data sets. So we really made a call out to the scientific community to contribute their data sets. Many of them we had no idea people were collecting, and people came forward with, you know, 20 some odd years of data from quite a large number of lakes on the ground. And so we had some criteria for inclusion that included, you know, really continuous record that was matched with the time period when the satellite measurements were available. But ultimately, when we published that data set, the data set includes even the lakes that we didn't include in this particular study. Some of them might have had records that were not quite as complete, but that data set will have lots more lakes in it, and it's public, and we really encourage people to get into it and use it.
Are there any other questions from reporters in the room?
George Drake from South Lake Tahoe. Would you give us the access to this data sets?
Yep. Yeah, it's I'm sure it's referenced at the back of our paper, and it might also be in the supplementary stuff that the reporters got, but it is Sharma et al. So Sapna Sharma is the lead author on it, and the reference is certainly in the back of the paper if you want the full reference.
Are there any other questions on the chat? Okay, then thank you very much. That concludes our press conference.
Great.
Thank you.
Thank you.
Thank you. Our next press conference is at 2:30, Discoveries from Real-Time Tracking of an Underwater Eruption and the Future of Deep Sea Research.